I'm Paul Mason, and this is Venus in a nutshell. Now, Venus, oftentimes called the evening star or the morning star, is seen typically at night before, just after sunset or just before sunrise. And so we can see that it is the brightest object in the sky other than the sun and the moon. And Venus is several times brighter than the brightest star in the sky, and brighter than any other planet, with Jupiter coming in second. Now, it's not always bright, but often it is, and when it's in the right position. Galileo discovered the phases of Venus, which was very important in determining whether the Earth orbits the Sun or the Sun orbits the Earth. And so Galileo's observations of the phases of Venus proved that Venus does orbit the Sun and not the Earth because of the phases, and we can see that here. When Venus shows a thin crescent phase, it's also very large. And when it has a gibbous type phase, it's very small. And this is because it's going around the sun and it changes its distance from the Earth, as we see in this diagram. So we can see a very thin crescent phase here, and it's nearer to the Earth. When it's in the gibbous phase, further around in its orbit, it is substantially further away, and therefore it appears smaller. So Venus was very difficult to observe in much detail. No moons were discovered of Venus, and when we observe Venus from the Earth, usually only thing we have is a planet covered in clouds. And this is also true for spacecraft missions, but this is the photograph taken of the Mariner 10 spacecraft that flew to Venus and flew by Venus. Now, the Magellan spacecraft had a different view. The Magellan spacecraft was able to map the whole surface of Venus with radar. And so the radar was able to penetrate the clouds and come back and be detected. And these were long wavelength light used. They could pierce the clouds and determine how far down all of the surface features were to produce a map of the surface. And so the Magellan spacecraft provided us with our view of the surface of Venus. Now, Venus, compared to Earth, about 88% of the size of Earth, and so to scale, this shows that Venus is not that different from Earth in terms of the size. One of the obvious differences here, though, is the Earth is covered by water and clouds, and in this depiction, we do not see the clouds that are normally here. We are seeing the surface with the clouds removed because it's a radar map. So here is an image of the surface by the Venera 9 spacecraft, and we can see rocks on the surface. We don't see a lot of cratering. We see lots of rocks from lava flows that come from volcanoes that are active on Venus. And so here is a depiction of both sides of Venus from the Magellan maps. And we look, this is Maxwell Montes, the highest point on Venus, and a volcano. And so we can see, now these images aren't really true color necessarily. They are enhanced in order to bring out the details. But we can see this volcanic mountain and these regions of plains where the lava has flowed onto the surface. And there are these kind of pancake shape or corona features, which are large circular kind of features on the surface. Now, Venus transited the sun, and when it did, we can see the size comparison. Now, keep in mind that the sun is 3 times further from Venus in this picture and appears, of course, much bigger. These transits of Venus only occur a couple of times every few hundred years. Here we have the structure of Venus. We see that there is a core that is iron. In here we have a large mantle, which is molten rock, and then a relatively thin surface. No plate tectonics, but Venus does have active volcanoes. Venus also does not spin rapidly. It spins very slowly, once every 243 days. And because of its slow spin, it has no magnetic field.